Hello and welcome to today's daily Leetcode challenge. We're going to be solving the solution, going through my thought process, and stick around for the end of the video where we compare our solution with the solution of others. With that, let's begin question 1615, maximal network rank. So there's an infrastructure of n cities with some number of roads connecting these cities. Each road, A, B, indicates that there is a bidirectional road between cities A and B. The network rank of two different cities is defined by the total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. The maximum network rank of the infrastructure is the maximum network rank of all pairs of different cities. Given an integer n and an array roads, return the maximal network rank of the entire infrastructure. Okay, so let's boil this down to some computer terminology. We're given a graph. We're given a graph with a bidirectional graph of something called cities, and we have to pick out the two nodes. And each node has some number of edges. We have to pick out two nodes such that the sum of all the edges for both of those nodes is maximal. And if there is an edge between the two nodes, it's only counted once. Okay, so it's pretty simple. Let's see, let's look at some examples. We're given 0, 1, 2, 3, and these are the roads from 0, 1, from 0, 3, 1, 2, and 1, 3. And the solution here would be to pick out 0 and 1. We could also pick out 1 and 3. And but we don't have to pick a specific city. We just have to give the output. We just have to say that the rank of that infrastructure is 4. I see. Okay. So it doesn't matter if we pick out 0 or 3, we would still get 4. Okay. And the explanation is the network rank of cities 0 and 1 is 4, as there are 4 roads that are connected to either 0 or 1. The road between 1 is only counted once. And something very similar here, except in this case, I believe that we are, no, see, 1 could also be 3. And here the answer is 5 because together the sum of all the edges between 1 and 2, and not between, just the collective sum of the edges for 1 and 2 is 5. 1, 2, 3, 4, 5. Okay, let's begin the implementation. Actually, no, sorry. Before we begin, how do we solve this? Well, my first intuitional step is that I want to have a data structure that immediately tells me how many edges a node has. And that could be easily accomplished with something like a dictionary where the key is the city and the value is the number of edges. That way, looking at a specific, or when I'm looking at a specific edge, I could very easily see how many edges it has, right? So that's probably going to be somewhere in the solution. And what else? We also need this this one step that basically tells us, we need to make a decision at some point that if we pick out two cities, is there an edge between them, right? And that could be easily accomplished with like a set of roads. Once I have that, I could just look through all the combinations of the two cities and have like a running maximum, right? It wouldn't really be a running maximum, but since I'm going through all the iterations of all the combinations of the cities, I could just pick out the maximum, right? Update the maximum. Okay, well, now let's begin to the implementation. So I said before that we're going to have a rank, which is just going to be a default dict with a default int, meaning that for a city, the initial step is that we don't know what the rank is, right? And then we also had something called the roads set, and that's just going to be a set. Let me populate this quickly from 2, 4 to in roads. I'm using a tuple here because a tuple is hashable. It's important. If this was a array, it wouldn't be hashable. And now let's populate. I'm gonna actually skip this for road in roads. Rank road. Let me do this from to from plus equals 1 and rank to also plus equals 1. So pretty easy. Let's just make sure that we're seeing all of this correctly. I like to do intermediate sort of print statements to make sure that I'm on the, I could spell, that I'm on the right path. Road set, and I have a dictionary with all of that. Perfect. Now let's have the for loop, right? And so it's going to be a nested. There's going to be 2 for loops, one going over the first potential. Well, how about this? For city 1 in range n, and now I don't want to overlap. I don't want to go over same combinations more than once. So I'm going to say c plus 1 to n. I'm going to say the sum of the edges of those 2 cities being picked is going to be rank of C1 plus rank of C2. Those are just the 2 cities. And now a quick condition that if let's have this tuple C1, C2 in roads set, or, and now we switch them because we don't know if C1, we don't know in which order they are. I'm just going to say S minus 1 because I'm just subtracting 1 because there's a common edge between them. Maximum is going to be initially 0, but now it's just going to be a max of this and S. Return maximum. Pretty easy. So sweet. Let's see, first try. First try. And beating around 77%, about 80%. Not bad. Okay. Quickly go over the solution one more time before comparing. The idea is pretty simple. We have 2 data structures. One is going to be a way of keeping track how many edges a node has. The second one is just to be able to identify a edge that is in both of the cities. And those are the road set and the rank. First I populate the rank. default dictionary, and then I go through all different combinations of the cities, of the two cities that I want, to find the maximum. Very simple. Simple and easy. Okay, let's look at some solutions here now. Also, again, running not significantly faster, but, well, it's a lot of code. Let's pick out something. Doable. Okay. This one looks good, right? And it's what? It's so very fast. Okay, so let's look at this solution. It seems like they have a helper function called makeGraph. And what does makeGraph do? MakeGraph takes makes a 2D array of the dimensions n by n with initially all the zeros, and then makes another array of size n also with all initial zeros. Then for road and roads, it populates the graph, the 2D array, with ones for representing an edge and intersection. Got it. And also keeps track of how many connections, how many edges each city has. So actually this is a very clean and probably faster way of doing what we did earlier, so I might adopt that. But then, let's see, they build this graph and it returns these two structures, graph and edge. And absolutely doesn't have to be a helper function. The result is going to be what is like the maximum, and then here they are doing the same exact thing, but somehow, let's see, somehow they've moved away from having to use a how did they move away from having to use a structure to subtract the 1 if the two cities are the same? So edge I, what is edge? Edge is just the number, and then minus 1. I see. Graph ij would be 0 in the case where there is no there is no cross road, and there would be 1 there if there is. And the max is okay. I like this solution. Let's try doing this. Let's try quickly. So graph is equal to 0. There's always issues with this. Hold on 1 second. My apologies. There's an issue where if you build a right, that's what they're doing. Although no, this is right. Got it. My apologies. The graph. Let's restart this from scratch. Confirm. Graph is going to be a 0 times n for in range n, and then we're just going to have the rank also, which is just going to be 0 times n. If I was to print graph and print rank, I would see that I have one 2D array with all zeros and one 1D array with all zeros. Perfect. And now I have to populate it. So for row, let's say from to in roads, I'm going to say graph from to is equal to 1, and just like that, I'm going to say from also equal to 1. Is that right? Yes, that's right. And then I'm going to have rank from frm plus equals 1, and the same goes for 2. Print graph and print rank. Let's see what this is doing. Awesome. And finally, maximum is equal to 0 for C1 in range n. Oops. For C2 in range C1 plus 1n. And I'm going to say here, maximum is equal to max of maximum or what is this? Rank C1 plus rank C2 minus graph, and it doesn't matter whether it's C1 or C2, return cleaner. Agreed. This is cleaner. Hopefully no mistakes. Hopefully it runs faster. Probably eating in on some of that time. Yes, definitely faster. Okay. Yeah, I can't say anything. This is cleaner and faster. So, okay. With that, thank you for watching. Please like and subscribe for more easy and fast solutions. All right, bye.